In this video, we're going to look at how we find limits graphically. Now we'll say graphically as opposed to numerically, where we would put numbers into the function to see how the y values are behaving, or analytically, which means we'd use some limit laws and some algebra to find these. But we're going to be doing these all graphically. So our first example, and all of our examples in fact, will be referring to this particular graph. But our first example, we want to look at the limit as x approaches -4, and then there's this plus that we'll explain in a moment, of our function f of x. The plus, where the exponent usually goes, is telling us direction. Now if you think about the real number line, over here we have the positives. On the left we have the negatives. So that plus means we're coming from the positive direction, from the right. This tells us x is approaching -4. Okay, we want to come from the right. So what I want to do is imagine that I'm on the graph. I'm looking at y values. Limits are talking about y values. So over here, right around between -2 and -1, the y value is 3, then 2, then 1, then 0, and -1. And as I get really close to -4, the y values aren't equal to, but they're really darn close to -2. Okay, and that's precisely what the limit is asking for. What are the y values getting close to when I approach my particular number? Okay, and if I want to, because I'm approaching it from the right, I could ignore everything from the left, and I can even ignore exactly what happens at x equals -2. So as we said before, the limit is going to be equal to -2. For our next example, we're going to see what happens as we approach -4 once again, but this time we're going to do it from the minus, from the left. So as we did before, we could scribble out, see how well we can do this, everything to the right of -4, and we can even, limits don't let us find out what's happening at that number. We could even scribble out what happens right at -4. So again, the minus sign means we're going to approach it from the left. Well, my y values are creeping along there. They're creeping along, and it seems like my y values are approaching this number 6. Okay, again, we're creeping along from the left, and the y values are approaching 6. Okay, so my limit here is going to be equal to 6. For my next one, we're going to look at x approaching -4 again, but this time we don't have a plus or a minus sign up there, which means that we're going to have to consider it from both directions. Now, limits, we don't care what happens directly exactly at that point. So I'm going to not worry about what's happening there at -4, but I want to approach from both sides. So on the left, we already discovered that the y values are getting close to 6, and on the right, the y values are really close to -2. We cannot approach two different values, negative or positive 6 and -2. If we do, we say that the limit does not exist. So does not exist. That's what DNE will mean for us. Why didn't it exist again? Again, it didn't exist because yes, the y values on the left are approaching a number 6, the y values on the right are approaching some number -2, but 6 and -2 are not equal to each other, and so therefore the limit does not exist. What about f of -4? Well, when I'm actually finding function values, what I want to do is I want to ignore everything around it. So I don't want to know anything that's happening over here. I want to stop when I get closer. I don't want to know what's happening on the right. I want to know what's happening exactly at -4. And if I did colored it enough, the only thing I would be left with is that filled circle, that open circle. We really don't want to, we want to imagine that it's not even there. So the filled circle happens to correspond to the y value of -2. So here the function at -4 will be equal to -2. In general, what you want to do, if you're looking for function values, you want to look at what's happening right at that particular number. Ignore what's happening to the left, ignore what's happening to the right, what's happening right at that particular number. If you find a closed circle, that's what we're going to go for. Alright, well now let's look to see what happens as x approaches -1. Again, notice there's no exponent like a plus or a minus sign, and so we want to approach it from both sides. As I said before, ignore what happens right at -1. I don't care what's going on right there. So I block that out. I want to look what's happening nearby. And nearby, regardless of the side I approach, it seems like the y values are getting really close to 7. Look, as I move up there, from the left, the y values go from what? 3 to 4 to 5 to 6, and then they creep up to 7. On the left, or on the right-hand side, I go from 5 to 6, and it seems like they're approaching 7 there as well. So my limit here is going to be 7. Again, I blocked out what was happening exactly at -1 because I don't care what's happening there. I care what happens near -1. And that, if you remember, is the definition of the limit. What happens to the function when x is close to but not equal to our value, and in this case that's -1. Okay, so here we have another one. We're actually finding a function value as opposed to a limit. Since it's at -1, what we can do is, again, ignore what's happening to the left of -1. Got to be careful here, don't color out too much. Ignore what's happening to the right of -1 and see what's left. Okay, well, the open circle, remember, is like a hole in the graph. We don't count that. But here I see that I have a closed circle. Almost colored my stuff out here. Right at the y value of, -5. So my limit, or my function value at -1 will be equal to -5. Got a few more to go here. We're going to approach this time 3, so x equals 3, and we want to do it from the left. The minus sign, remember, indicates that we're coming from the left. So ignore everything that happens on the right. We don't care about that. Again, we don't care what happens exactly at 3, just what happens before 3. So we follow things. We're coming down. We go 5, 4, and it seems like the y values are getting really close to y equals 3. So our left-hand limit here is going to be 3. Okay. Now sometimes you can kind of focus on that circle that's there and say, well, it's a filled circle, but just to the left of it, that's really close to that where that filled circle is. Yeah, that's going to be 3. Okay. All right, as you might have guessed, this time we're approaching 3 from the right. So once again, we don't care what's happening to the left. We can ignore that. Obviously, we're not going to scratch this out on a test or anything, but ignore all of that. And then follow the graph as we approach 3 from the right. As we approach from the right, notice that the y values don't really seem to be approaching any number. And even if you look very, very closely up here, there still seems to be some space between the little grid line for x equals 3 and the graph. It seems to me that the graph is going up and does not want to stop going up. Okay? And in this circumstance, I'd be inclined to say that the y values get as large as we want, and when that happens, we say it approaches infinity. Some books even say we approach positive infinity. Now, when I say the y values get as large as we want, that's exactly what I mean. If I want to get to 1,000,000, there must be some number just to the right of 3 where when I put that number in to the function, I will exceed 1,000,000. And if I'm between that number, let's say 3.0001, maybe that's that magic number. If I'm between 3.0001 and 3, all of my y values will be greater than 1,000,000. Or I could even pick another arbitrarily large number, 3 billion. Eventually, I'll be able to get close enough to 3 that all the y values will be larger than that. Just 4 more to go here. What is f of 3? Again, f of 3, we don't care what happens exactly or around 3. We only want to know what happens exactly at 3. As I said before, remember there was a little space between the grid mark and the graph there? All that I'm left with there is the closed circle right at y equals 3. If I wanted to put coordinates on that point, I would say that was the point 3, 3. And so my limit is the y value that I see there, or this isn't the limit, I'm sorry. The function value is the y value, which is exactly 3. All right, now this is an oddball one. With all these other ones, we approached, what, -4 and 1 and 3. All the graphs there, or the graph there, always had something strange going on. What happens is x approaches 1. Again, I don't care what's happening at 1, so I could block that out if I want. But near 1, the y values are all kind of hovering around the same, all hovering around the same number. And that number appears to be y equals 4. So I think that the limit as x approaches 1 of my function is equal to 4. Now, this is not one of the slides, so I'm going to have to write this in. But if I were to erase that, remember that line, the vertical line that I drew here? It went through precisely at that y value. Okay, we would also have that f of 1 is equal to 4. And when this happens, this is just a little preview of things to come, we say that the function is continuous at x equals 1. A function is continuous at x equals 1 when the function value and the limit are equal to each other. All right, well, 2 more here. What is the limit as x approaches infinity? That's a new one. Okay, so what this is saying is we want to take larger and larger and larger and larger x values. Okay, well, starting down here at 1 isn't very exciting. What I'd really want to do is think about 1 million. Well, I don't have that on the graph. Or then 1 billion or 1 trillion. I don't have those, but I can look to see what's happening in the graph and kind of make some assumptions as I go. I see here that the graph seems to be really tapering off very quickly, and the y values seem to hover right around -6. Again, I would trace the graph and see what's happening to the y values, but they all seem to be hovering right around -6 when x is really, really, really large. I'm just taking a guess here, but from the graph it appears that the y values are close to -6. And we call that a horizontal asymptote. Be very careful how you say asymptote. There is a p in there somewhere. And the final, what happens as x approaches negative infinity? Well, this time I would go off to the left on the x-axis. I would go in this direction. Okay, but what I do is I do it on the graph and see what happens. Well, I'm going to start on this little segment, and I notice that the y values seem to be decreasing at a steady rate. You know, I go over a couple and I'm down 3, over a couple, down 3, and it doesn't seem to ever stop doing that. The y values seem to continue to drop forever. And so in this case, I'd be tempted to say, it looks like the limit is negative infinity based on the information that I have. I don't know really what's happening past -6, but if the trend continues, then I certainly would expect that the limit would be negative infinity.